Okay, perfect. Sorry for the tardiness, but the person who was supposed to announce Szymon got late, which is me. Sorry about that. So it is my honor to introduce Szymon. Szymon is the person who actually is behind every single webinar, making sure that you can see on YouTube that he created the Discord space, and he's the principal force behind the seminars. So first of all, very warm thank you for that. Yeah, and Szymon is a PhD student at the Lodz University of Technology, and he joined our society last year after NGSchool 2019, and as I said, he's been a very active member, and he will talk today about the GitHub, Git version control. And I think one other thing I'm going to tell you is that you can see more about our NGS seminars on the website, and we will talk at the end also about upcoming virtual symposium, which you can also check out on our website. But in the meantime, oh, by the way, website was also done by Anna Maria, Ula, and Szymon. So again, as I said, a very active member. And I'm very eager to see what Szymon has prepared for us for version control with Git and GitHub. So the floor is yours. Thank you very much for doing this.
Thank you very much for the introduction, and welcome everyone. Yes, as Kasi said, I'm going to introduce you to Git and GitHub. Yeah, as you can see, this will be a very practical webinar. So yes, we have the presentation, but we're also going to be doing some live coding, which is going to go great, I suppose. Yeah, let's start with what actually a version control system is. Suppose you're I don't know, programmer or a scientist working with code, or any other person that would like to keep a history of their files. Also, for example, artists or designers who change their projects. The main features of such systems are that you're able to easily compare the changes over time. You can view who and when changed which portion of the project. Then you are able to go back to modify those files from any other previous version. And also, the important part that we are going to talk about today, it allows for cooperation, and for cooperation that is transparent, that is, everyone knows what they're supposed to do, and you can easily verify if that has been done. So, with that, Git. Git is a version control system, and it is a distributed one. What it means, I will describe in a second. The main features is that the repositories of Git are mainly local. That means that you don't have to be connected to the internet all the time. You can easily develop the project on your machine only. It also introduces 3 stages of files, which are going to be very important, and I will also explain in a second. It allows, as most of the version control systems, for preservation, integrity of change history. And then it introduces something that is not very common in those types of systems, which is a branching system. So let's begin with this model. Here we can see a centralized version control system, which basically means that each of the developers has to be connected to the shared repository to commit, to save any changes that they have done. And this is a very tight connection, so they are not able to save any changes if they don't have an internet connection or local connection to this repository. On the other hand, we have a distributed system, which means that each of the developers has their own copy of the repository of the project on their computer, and they can share it with any other person on the project. However, usually there is a shared repository in the project, but as you can see, it is not a tight connection. It is very loose. So every person can develop on their own, and then if they have a connection to the repository, they can upload these changes. Yeah, going a bit deeper into this architecture, the 3 stages. So each of the developers is here marked with local. So this local stage is present on every developer's machine. We have working directory, staging area, and repository. And these are the 3 states of files that the files can be in. The first one means that are for the files that were either added or changed. Then the staging area is sort of a way of marking those files that we want to save to the repository. And then we have a repository, which is a sort of a ledger, sort of a place where we store those changes and the files. The remote part is also important, however, not for now. I will explain it in a bit. So what are actually those commits that I've been talking about? Git, unlike most other version control systems, does not store the changes between time points in the project, but it stores the snapshots. As you can probably see, each commit stores a snapshot of all the files in the working tree. A working tree is simply a saved structure of your directories and files. And then each next commit is connected to the previous one and has a reference to this previous commit. Okay, let's get into Git more practically. So if we want to start working with Git on a new machine, there are a few things that we have to configure. So Git identity. This is a way of identifying who is creating the commits from this machine. So we have a command git config. Then we pass a few parameters. So first of all, global means that this setting is set for the whole machine. Then username, and we pass some name that we want to use on this machine. There's no output, but it was saved. Then the same way, we must pass this email. So without setting this name and email, you will not be able to commit anything from the machine. Okay, this is saved. And how to check what are the values? We can go to git config. It is in our home directory. And we see that name and email is set to the proper values. So this was the required configuration. Okay, if we start working with any new project and we want to, if you want Git to know that it is a repository, it is a Git repository, you have to go, use Git init. And so we will. Here are the directories that we're gonna use. Actually, yes, I've created this NGSeminar directory, so let's get into it. And it is empty for now. If I type git init, you can see that we have initialized empty Git repository, and now Git knows that it can operate in this repository. Yes, if we see that, if we see the tree, we see that Git has created this special folder .git, and in this folder, Git stores all the information of about this repository. Another very useful command that you're going to be using all the time is git status. It shows the status, as you can guess, of our working tree in the repository. So there are a few things here. We are on the branch master. Branches will be explained a bit later, but we are on master right now. There are no commits so far, and there's nothing to commit because we've just created this repository. So if we want to, we can create a file. I'm going to be using Vim because I can use it in a console and it's just easy. So let's create some file. Okay, this is an example. We've created this file and now we want to commit it, save it in the version control system. So it is present. Let's check git status. And now we have one additional information. Untracked files main.py. That means that this file was created, but Git doesn't know if it should track it, if it should know about it. So the way of letting Git know that it should care about this file is by using git add and then the name of the file, git add main. Now, if we use git status, we see that this new file is tracked by Git and that it is supposed to be committed. Going back to our 3 stages, this file is now in the staging area. So it has been moved from the working directory to the staging, which means that we want to actually commit it. And how do we do that? With a git commit. However, it's not enough. You should always provide a message for git commit, and this message is supposed to concisely and clearly describe what you have done in this commit. So yes, we added a main file. So this is a pretty good message. As you can see, we've created a commit. I will explain, but this commit was made on master branch, and it was given some hash value. The hash value is just an identifier used to mark each commit, and you can later refer to it by that identifier. So let's look at our status. And since we have committed this file and there's now no other files to be used, there's nothing to commit, as you can see. And now for the more practical part of the webinar. Yes, I am going to show how to use the commands, but I also give you a few best practices to use. So, as I said, commit messages are used to quickly, are used so that other developers and you later in the project can quickly see what has been done in that commit. And for that reason, we should keep those commits not messy. So instead of writing commit in those messages, whatever, it is actually much better to apply some standardization. I really like this this standard. Well, not standard. Proposition by down here. I really recommend to read this article, but to summarize it, here are the most important rules. So first of all, limit the subject line to 50 characters. That basically means write short Git messages. nobody wants to read the whole story about why and how and what have you done. Just summarize it in a few words, and then use the imperative mode in the subject line, which means, according to these rules, you should write add and not edit, for example. So that means that someone can say, if applied, this commit will add main file. This is a way of remembering that. Okay, so another stage in our project. So we've created a file, but now we want to change something in it. So main. What if we want to add another line to this file? Yes, I'm copying because I've it prepared. So we want to add a line hello world here. Let's save and exit. And now if we use git status, we see that this file, previously it was shown that it is an untracked file. Now that it has been modified, and the main .py file has been modified, but how has it been modified? We can use the command git diff, which will show the differences in the tracked files in Git repository. So here, I know that these are both green colors, but you can see that it is marked with pluses what has been added. So we've added this line with print statement and an empty line. Also useful to know, you exit this mode with Q. So these were some simple commands that you can do on your own if you only want to develop a simple project, simple application. But what if you, for example, wait a second, okay. Yes, what if you want to, okay. What if you want to do something more complicated? Let's also add this main file, since we've modified it. Git commit message, I don't know, at hello world message. Okay, we've committed it. And now let's go to Git branching, which is the main, let's say, set point of Git. This is how our repository looks right now. We've made two commits, one adding the file, one modifying it. And another thing that I'm going to introduce, this is a head. This is a current head, which means head is a sort of pointer that points to the current branch and current commit that we are placed at. And if we commit another message, we would add another commit here, and the master pointer would move to this commit, and that would be the head. However, let's suppose that we don't want to modify anything in a master branch. Let's suppose that someone else is using that branch and we don't want to break it for now. So what can we do? We can create another branch. That can be done with git branch command and then the name of the branch. So let's call it test. However, as you can still see, the head pointer marked in a dark red here still points to the master. So how do we change that? We can use git checkout test. And git checkout is basically used for switching between branches, and then we give the name of the branch. So we've switched to it. And now if we do any commits, those commits will be on the branch test. Okay, so assuming that someone else has made a commit on a master branch, we are going to now create a file called graphs.py. And in this new file, we want to include some stuff in it. It doesn't really matter. It's we save it. Git status. We use git status a lot, as I've said. We see that graphs is not tracked. So let's add it. Graphs git commit graphs. And what has happened now? We've committed this, and we have committed it to the test branch, as you can see. So what is the situation right now? This is how it looks like. The master branch goes with its own way, and we are going our way. Okay, assuming that something has happened on master, we have made another commit, and now what if we want these changes to be used on the master branch? Assuming that the master branch is our main that is visible to everyone, what if we want to merge those changes? Well, there's a command called merge, which is quite easy. However, first you have to switch to the master branch, git checkout master, and then you can git merge test. So git merge, and then the branch which we want to merge into our current branch. Here's a quick summary of what has changed. We've added 8 changes in the graphs.py file, and now this is the situation. The master branch has been going its own way, and test has been going its own way, and the result is that we have changes from both of these branches together right now. Another command which is useful is git log, and as you can imagine, it shows all the commits that we've made, the newest one being at the top. So we've added main file, hello world graphs. We can also see that right now head is pointing to master. However, the test branch is also at the same commit right now. We also exit it with Q. If you want a more visual way of looking at that, where are we? Right branch test. That's gross. Yes. There's one thing that I've skipped, unfortunately. Let's. Okay, so now the graph shows only a straight line because I have not committed anything on the master branch. However, if I did, we would see that the master branch goes here and the test branch is on another way. In reality, these branches are actually more complicated. As you can see, this is a real project, and it can get really messy. So it's good to understand why and how those branches work. Also, another interesting, let's say, best practice, but it is for bigger projects which should keep track of versions and tags, and it is, I don't, not specifically for scientific purposes. However, it's worth checking out. Is Git Flow Model, which defines how you should, which branches you should define, how to name them, how to commit. If you want to, you can read about it. Also, I will post this presentation online later, so all the links will work for you. Yes, another thing you can think about is what happens if we have two branches and two different people change the same thing on those two branches. How would Git resolve that? And yes, we can merge those branches. However, we would create a lot of conflicts. So let's fabricate this situation. We are currently on the master branch. Let's change this parameter. We've changed this. We have git status, git diff. We see that we've changed one parameter, so we can git commit. There's also one other parameter that you maybe would like to know. It is -a, which means that it will commit all the files that are prepared for staging. And then git message change first parameter. We've done that change, and now let's check out to the test branch. If you look at the git log on the test branch, we can see that the last commit was adding graphs. So we have not changed this file yet on this branch. Basically, between branches, the files can differ, which means that you are able to change the files on one branch and not on the other, even though they are all physically on one computer. So let us edit that. And on the master branch, we've changed this to 0.2. What if we change to 0.5 right now on the test branch? Git commit all message increase the parameter. So we now have two commits on different branches that modify the same portion of the file. Let's see what happens. Git checkout master. Let's see what happens if we try to merge this test branch to the master one. Yes, this is the very scary thing that many developers really hate. However, it is also very common, so you should expect to happen. As we merge, we see that there are merge conflicts in graph.py file. And how do we resolve those conflicts? Well, from the command line, we have to we can edit this file, and as you can see, on our current head, the file looks like this. So this value is 0.2. However, on our other branch that we are merging, in this example test, this value is 0.5. And now we, as the person who is merging, have to decide which version is the right one. So let's decide on the test one. This is a very manual and not preferred way. However, let's do it like that. Exit. And another thing that we have to do, and Git tells us about, fix conflicts and then commit the result. So we have changed this file, but we have not committed it yet. Then we write the git commit. For merges, you don't really have to use a message. However, you can. Yes, I've forgotten add graphs. Then git commit. And this is a typical representation of what a commit message and body looks like. So the first line is the message, and we can then write the body of the commit. However, let's leave it at that. And we merged this branch test. And now I can show you the graph. So we've changed the first parameter on master, we've increased it on test, and then we merged this branch called test. So as you can see, the head where we are now points to master, and the test branch is present here. So if we switch to the test branch, our history would go through all these commits, omit the master commit, and stop here. Let's exit. Let's now get to the sort of configuration of what Git is able to do with our files. Let's assume that we have some sort of files in our repository that we don't want to commit ever, that we don't want anyone else to know about. This is quite often, for example, with logs of your application. So you don't put your logs in the repository because nobody else cares about it. They're only for you. Let's create, I don't know, error log. So now looking at our directory, we can see that we have 3 logs that somehow exist here. However, if we now use git status, we can see that Git is able to add those files and commit them, but we don't want that. So a file that can prevent that, and we should create this file in the main directory of the project is git ignore. .git ignore. And here we can define rules for Git to understand and obey of how it is supposed to treat the files that we have in the directory. So a few examples. If we paste like this, so asterisk .log, it means that Git will now ignore all the files that end with .log. Let's check that. And as you can see, there are no log files detected by Git, but there is another file that Git has detected, and this file should also be included in your repository so that other developers don't commit those files as well. Let's add it. Git ignore file. Great. However, what if we don't want, for example, to ignore the important log? What if this is something that our application needs for working, and other developers would like to use that too? We can use a rule which tells the Git to ignore all the log files, but not this one. By the way, this you can also use stars. You can use any patterns in here for detecting the files and the directories. So, Git status. Now we see that all of the log files are ignored. However, Git is able to include important.log. And that is what we wanted. A few other rules. For example, data. If we create a directory called data, and then we, I don't know, something dot we can see that in this data folder we have some data, and typically you don't want to commit data to the repository. The main reason for it is, for example, this can be some personal information. Maybe you have some not anonymized files, and if you upload it to the repository and then you publish it to a public place, then everyone can see it. The other reason is that sometimes those files can be really large, and typically Git is very fast. However, if you load it with unnecessary files, it will slow down, and you don't want it to happen. So if you don't have to upload your data, it is not critical for the application to work, don't do it, I'll say. So we've created this repository. We've created the rule of ignoring this data directory. And we see that Git does not want to include it. That is really good. Another rule that I've written here is if we put a slash at the beginning, then Git knows that this data directories should only be excluded from the root folder of the project. So let's look at it. The structure is like that. If we create a make dir public, then we create make dir you see that now we have a public directory with data inside it, and supposing that we want to share this data, let's see Git status. Git still doesn't know about this data directory, and this is not what we want to do. Let's also create something fast. We can change that with modifying gitignore file. Actually, with modifying it. And now, even better, you can use all, I think. Yes, to show the full paths. And now we only exclude the data folder from the main from the root of our project and not from anywhere else. So this is really really cool, really useful for not leaking your data that you don't want. Typically, you also store passwords in the files that you include. You can store some connection details to your database, I don't know, anything that you don't want to share. Here I've pasted also a website that allows you to quickly search for Gitignore files, templates. So suppose you want to use, for example, Jupyter. We click create, and here we have a template for if you're creating, if you're using Jupyter notebooks. We can use anything else. Yes, in R. You have another template. You can copy it, paste it into the root of your project .gitignore, and it will exclude the files that typically you don't want to. So, moving on. This will be important a bit later. However, I want to talk about it right now. It is also a part of Git language, let's say. Stashes are used for storing our changes in a separate place, and those files will not be seen by Git for adding to the staging area or for committing. So it is useful if you don't want particular files to be committed to the repository. Let's see the example. Okay, so we can actually use our tree git stash. What's going on? Git stash. Okay, so right now, okay, let's start with git status. Here are 3 files that would be normally added if you added them all to Git, and there's one thing that you can do to prevent it. So if you write git stash, Git tells us that we've saved working directory on master something. What does it mean? What does it mean? It means that we have hidden those files that we've created or modified since the last commit. So as you can see, we've hidden gitignore and all of those files that would normally be included. The situation now is a bit more complicated, since now we can see that Git wants to use these files. Why is that? Well, we've hidden gitignore. Git doesn't know about it, so now it thinks that it can include everything. With git stash list, we can see all of the stashes that we've created, because we can have a lot of them. With git stash show.a. With that command, we see what we actually stashed, and it only shows gitignore because git diff only shows the files which are already tracked by Git, not new files. And then if we want to bring those files back, that is, if we want to use them once again, we can either use git stash apply or pop. They both retrieve those files from the stash. However, the difference is that apply does not delete the stash and pop does. So assuming that we don't want to use this stash anymore, we can git stash pop. Now git stash list. There are none because we've popped it. And we can see the previous state that we were in. We have gitignore and some other files. There are also a lot of other topics that maybe we'll have time to talk about. We'll see, but Git is a bit more complicated also. You can tag your commits, you can use rebase, which is that's not strictly true, but a variation on Git merge. Then remove is used to remove the files, but from the repository, not from your file system, but from the repository. With Git reset is used to go back through your commits. So the thing that I've said at the beginning, Git allows you to go back through your history and start from another point in your log, in your history. So this is git reset, and also an interesting command, which is git blame, which I'm gonna use right now. Let's graphs. Here you can see. Okay, so I've used git blame and then the name of a file. And here we can see this file line by line, seeing who has made the last change to that file, to that line, when, and also a commit identifier for reference. So this is a useful tool. For example, see some change in a file and you want to see who changed it. You can just git blame, you see the list of all the lines, and then you can ask them why. So coming back to our 3 stages that I've talked about at the beginning. We have just talked about the local part of it. So we can see with git add command, you move the files from the working directory to with git commit, you move it to the repository. Wait, this is wrong. So now let's talk about the remote part, because as nice as it is to have the repository on your own machine, very often if you collaborate with other people, you also want them to see your changes. So you could send those files, for example, by mail, or those repositories by mail, but it is very not convenient. So you typically put it on a shared repository, which is usually a cloud-based service that is run by someone else. From those repository hosting services, you probably heard about those three. They are the most known ones: GitLab, GitHub, Bitbucket. And as you know from the title of the presentation, we're going to talk about GitHub today. However, the workflow for each of them is pretty similar, so you should be able to figure it out on your own if you follow right now for GitHub. Okay, so there is a GitHub flow. I've shown you before the Git flow, which is used for your local repository and the branches. However, on GitHub, it is a bit more complicated. For example, assuming that there is some open source public project, let's say NumPy. Let's refresh it. Okay. We see that they have uploaded all of their files from the library here publicly on GitHub /NumPy/NumPy. And we can browse through these files. We can see how this library works, and it's great. However, what can we actually do with this repository right now? The few things that are present on this page. First of all, code. This is what you see right now. You can browse the code. There are also issues on GitHub, which are used for example, for tracking bugs in your code, for adding some suggestions. For example, if you want to extend this library or add other functionality, or I don't know, whatever else, then there are pull requests, which I will explain a bit, and some other things that are not really in the scope of this webinar, but can be useful as well. So, as we've seen, right now on the NumPy page, how does the GitHub flow work? The first point: create a branch. It is typically in your local repository. You would do that by creating this branch, as I've shown. Git branch, then git checkout. However, on GitHub, you cannot just simply create a branch on a public repository.
Okay. Do we have Szymon back? I think we have some technical issues, so just bear with us for a second. I guess Szymon will reconnect. In the meantime, if you have any questions, just shoot them away at version control channel or on YouTube, and we'll be happy to help you out with any questions you have. Yeah, my first photo was also like, it's my internet that went off. I mean, yeah, but I guess it's on the other side. So, oh, great. We can see. I can see Szymon. So I mean the feed, the computer. So I guess everyone else as well.
Can you hear me now?
Yes, I can hear you, but I still cannot see your face. It's still like loading, but maybe it's only for me. But I can hear you, so I think it's gonna be good.
I can turn off the cam if it helps.
No, because ENJ is saying that he can see you. It's just me apparently. So I'll fix myself. Yeah.
Okay, so
yeah.
where did I finish? What was the last thing that you heard, if I can ask you all?
Okay, I forgot. So I'm not the great. I don't know. but Ariana is writing and okay. You were talking about the steps on GitHub.
We have seen
We have seen the NumPy repo.
Okay, sure. So I have to repeat a bit. So about creating a branch. Oh, okay, that's good. Okay, so let's talk about creating this. As I've said, on local, you can just git branch. However, here it is a bit more complicated. However, still not that hard. Here you have a button that is called fork. If you click this, it forks this repository, which means that it creates a second branch, however, not on the main repository, numpy/numpy. As you will see in a minute, it will create this branch on my own account. If it works. Yeah. Instead of, I mean, the situation is somewhat similar to this one. The main NumPy repository still exists in the universe. However, I am now creating another, let's say, another repository that for GitHub is called a fork. Okay, it shouldn't take that long. I'll show it in a second. Also, if you see any links, present some resources that will help you understand these concepts. Here are the official ones from GitHub, explaining GitHub Flow and other issues, for example, forking projects. Is it done? No, it's not. Okay, let's move on to another concept that can be a bit daunting for people. Usually, typically, if you have a GitHub account and you want to do anything with your repositories that you have there, you have to somehow authenticate yourself, that authenticate that you are the one who connecting with these repositories and not someone else. So if you just do it the simplest way, for every interaction with your repositories, you would have to input your login and password. This is fine. However, this can be a bit annoying. So there's another way. And this for sure also works on GitLab. I don't know about Bitbucket. And these are SSH keys, which mean that you can create a pair of keys, one on your computer and one on GitHub. And by these keys, those two places can communicate. This is a very high-level description of key pairs from cryptography. So let's do that. Here's a command for creating your key. Also, another thing, those keys are only created once for a machine. So when you create them, you don't have to do it anymore. Let's go for the command. This is a command. You use this algorithm, and then you give your email address. What is this? What is this? Is it not copied? Okay, so here's a generation process. Enter the file in which to save the key. If you have not generated any other files on your computer, you can just save it to this directory. If you have other keys, you should save it to another one, not to overwrite those keys. Let's click enter to use the default option. Then you can enter a passphrase, which you will have then to type every time you interact with the repository, and this is used mainly in access to your computer. So it is to protect your repository from being interacted with by another person. However, assuming that my computer is protected by a password that I log in with, let's not use a passphrase. That is completely fine. Enter the same passphrase empty, and we have created a key. Let's look into the directory where we have saved it. No SSH. And here you have a pair of keys. This is your public key, which will be used by GitHub or any other service, and this is your private key. So let's see how our cut ID is it not working? Yes, you are right. So this is our public key, and it can be shown right here because it is a public key. However, you should be careful not to show the private key. So we're gonna do just that. I mean, not really. We're gonna just show the head of this key, and it is also just some random string. So let's, without further introduction to this concept, let's run our SSH agent, which will be used on a computer to use those keys. Let's add let's add our private key to this agent, because our computer only needs the private key. Then we can copy this public key to the clipboard. However, yeah, I don't have here, so we can also use public. And let's do it. Okay, I don't know what's going on, so let's fork numpy as a copy. Yes, that's fine. Forking. Okay. If we go to GitHub and settings, then SSH keys, here are your keys, and let's add a new one. How do we, this is a title of our key, so typically it should be something that identifies our computer. Let's call it, I don't know, NG station. Yes, we have to confirm it with a password. And now we see that we have added this computer that I am working on to our GitHub keys. That means that I can now interact with my repositories from this station without needing a password. Okay, in the meantime, a fork has been created. As you can see, this is my repository called NumPy, and it was forked from the main repository of NumPy. It is important because I cannot make any changes to the main one, but I can make changes to this one. So how do I actually make any changes to this directory? I have to have it locally on my machine. And I can do that by cloning it. If I go to my main repository, main folder, here is the project that we have just created. However, I want to copy this this repository into another folder. So, NumPy, you can either click here, or you can just copy the whole link, git clone, and it will cloning into NumPy, so it will create a new directory, and then it will place all the files. Yeah, there's a lot of files here, as you can see. And now, if you go to NumPy, we have the entire library here. Now, if we want to make some changes, if we want to, for example, extend it, we can change those files. Let's do that. So here's the README. I'm gonna change something small because I don't actually want to upload this change to the main repository. That's great. Git status. There's one modified file in the whole repository. Okay, yeah, another thing that I'm going to talk in a bit. Let's git edit. Git commit. Proof readme file. Okay, so the change that I have just made is present on my local machine right now. I have changed the NumPy library, but it is still on my main machine. So how do I upload it to my GitHub? If I refresh here, or the comments, yeah. The last commit is still something that has been done on the public repository. But there is a command used for interaction with between the local and the remote repositories. It is git push. So, assuming, yes, that's what I was going to go back to. Git push, then we have origin master. As you probably guess, master refers to the branch that we have on our local machine. However, what is origin? Using this command, we can see what are the remote repositories that correspond to our local one. So this basically means download and upload in Git terms. So for downloading, we download from this repository, from this link, and we also upload to it. And currently, they are called origin. So this is just a name for the remote repository. We can also git remote rename region. It should work. And we have changed this name. It doesn't matter really. It's just something that we used to identify. We can also use many remote repositories for the same local one. And then if we want to interact with them, we would use the name of this identifier in the git push and git pull commands. So for is, let's change it back to origin. We have origin, and then we can write git push to which remote repository from which branch. Okay. Yes, this is sort of not supposed to happen.
I think, Szymon, you have origin at HTTPS. I think you should change it to SSH. So I think
yes,
it would.
You are correct. You're entirely correct. I think I've skipped. Yes. Let's exit this. The thing that I've shown, but I forgot to use actually. If we Git
I think you need to use set URL now. So like I only know it because I've done it so many times that I just remember. I think you can change the URL also with the Git remote set URL origin and then Git at GitHub. But I'm just saying what I would do. But it might be a different way to do it.
Okay. I don't know. Add should. Maybe I'm missing something. Okay. So basically, to explain what we've just done, with Git remote add, we are able to add new remote to our repository, and with set URL, you just change the URL. So now what is this? Git push origin, not origin, but origin new. We've changed it. And for the first time that you connect to a given host in this example GitHub, you have to accept this fingerprint. Well, you should check it. I'm just going to accept it. I've pushed the change. I've pushed the change to the remote repository. And then you see, if we go to commits, there is my commit. So on top of all of the other commits, there's also mine, which adds something to the README file. And then now this change has only been made on my account, on my repository. So what if we want to merge this change back into the main repository? There's a very convenient button here, which is a pull request. This branch is one commit ahead of NumPy master, which means that we've committed once in comparison to the main repository. If we click pull request now, this is a bit more complicated screen where you can see this is a pull request, which is an equivalent, let's say, of a merge request, which means that I am asking the administrators of the main repository of NumPy to merge my changes into their repository. In this screen, you can see that there is one commit, one file changed, here are the changes, and if I actually made some meaningful changes, I could create this pull request. I'm not going to do that because this is garbage, but I'm going to show you how it looks like from the other side in a minute. So, going back to the NumPy repository, the main one, we can see that there are a lot of pull requests. Let's go into one of those. Looking at the GitHub flow chart, what we have done so far, we've created a branch locally, which means in my project. We've made some changes, we've added commits, we have opened a pull request, and then typically what happens on bigger open source repositories is there's a discussion about why this change should be made and what it actually brings. For example, the administrators can suggest some other changes. We can then commit a bit more. We can add another commit, and after all this discussion, if everything is okay, we have a review. Should be. Okay, maybe not GitHub, but on GitLab. So the review consists of the administrators of the main branch seeing if they can allow this merge, and if everything is okay, which they can check by going to file changes, they can review what has been changed, what are the commits, and if everything is okay, they can merge it to the main repository. Typically, if you were in charge of such project, there would be a merge button at the bottom. So this is the process of doing basically the same branching and merging, however, on a more public, on a more global scale. And this is how it works with open source projects. So let's see it from the other side. That is from a project that is existent. So NGSeminar Git GitHub. This is my project, which I have created some time ago. And let's use it for the demonstration. So we have two folders in the seminar NumPy, and well, this work. I hope. Yes, this is exactly what we should done. Kasia is right. We should have used the SSH version of the URL, not the HTTPS one. SSH version means that we can use those SSH keys that created just a minute ago. Now, it has been copied to NGSeminars Git GitHub. Let's go to it. Git GitHub. We have those three files that are here. If you look at the Git log, these are the commits that were present on the public branch. Also, another thing that you see at the top, origin master, origin head. So, as I've said, origin is our designation for the remote repository, and the master branch and the head pointer on that repository is at this comment. Now, wait a second. So, if we are the administrators of a public remote repository, we can see that sometimes we will get those pull requests. That means that someone else wants to change our repository, and here's the change that someone has made before. So in our file analysis, which looks like this is some Python code, someone wants to change this method from saving to a CSV file to an Excel. And what can we do with that? We could yes, here's the button that I was talking about. If we click this, we will merge those changes to our main repository. So let's do that. It has been merged, and now we see that this commit is applied to our commit history. So we treat it as part of our commit of our commits. Now, what if we want to have this change present on our local branch? Let's assume that there are a few developers working on this project. They changed the repository. They committed to the public one, and now we want to have this this change present on all computers. There is a command called git pull. So as it was shown here, git push pushes the local repository to the remote one, and git pull is the opposite. So it pulls the changes from the remote repository to our local one. These are the main two commands that we use for interacting with the repository. Another issue that we should address for now. For now, my history looks like this, and the history of the remote repository looks like this, which means that I locally am at this point, and if I were to pull this this commit, it would be pulled with no problems. But usually the situation is not so simple. Let's change the analysis .py file, and let's assume that in the meantime, in the same time that we were accepting the pull request, we also changed something in the same line. So what, and also, wait, no. So what is going to happen if I try to now git pull those changes? If on the local side of things, we had those branches, we merged them, and we had a origin, yes. However, here we cannot do that. We cannot analysis. We cannot create those merge conflicts so easily. So as you can see, the only version that is currently available is the one that I have created locally. And why is that? Git, the remote repository, does not know about our local changes. And if it was to merge those two branches, it would simply override them and not create any merge conflict. So we would not know about our changes that we had beforehand. So it warns us that our local changes would be overwritten in those files, and it also aborts this git pull command. This is a safe way of doing that, so we don't destroy our local repository. So the two options that it gives us: we can commit our changes or stash them. So let's do the second one. As I've said, this is a legitimate use case for stashing our changes. Git stash. So we've saved our working directory to some stash. Git stash list. It is here. Git stash all. These are the changes from the previous commit. And now, if status. With Git status, we don't have any files that were changed on our local repository right now, so we can pull the remote one with no problem. Also, you can see a message here that my branch is 2 commits behind, so that would align with what we've seen here. There is this commit, and then the pull request is also a commit, so we are 2 commits behind. Let's now do what we wanted to do. And here you can see that we managed to pull those changes. In the analysis files, there was 1 addition and 1 deletion. So that is exactly what we see here. 1 thing was added, 1 thing was removed. Okay. Git log. And now our local and remote branch align. So this is a very simple workflow for working with remote repositories that other people also have access to. And it means that we are not conflicting with each other, we can cooperate. However, one thing that we've missed, we've pulled these changes, but we still have our stash. And if we want to now hit stash apply, now we want to merge our stash with the branch that exists that has been pulled from the remote one. And now since both of those places, a stash and our branch, are local, the merge has created a conflict. So we can now edit this file, and we can decide which part we want to keep. Let's assume that the contributor to our project was right, and let's delete our lines. Saved. Git status. Here, the status both modified means that 2 of the branches, 2 of the paths, modified the same file, and we have to decide what to do with it. We have just decided, so now we can edit, analysis, And another curious thing that has happened just now, as you can see, we had this file modified. However, after adding it to the staging area, there is nothing in Git status. Why is that? Well, basically, if we look at our last commit, the file was changed to, this line was changed to Excel, and we tried to change it to something, to something that is something else. Then we applied the stash, we decided on which to keep, and since the state of the file before applying the stash and after deciding on the merge request was the same, Git sees that this file does not differ in any way, so we don't have to commit anything. That is something that you may be confused about, but Git operates by seeing if any file has been changed, not but by the actions that we've done to it. So are there any questions for now? I would be happy to answer some, since we have some time to spend also. From the resources, I would really recommend Pro Git book, which basically covers everything in Git and explains why those commands work as they do and what you can do with them. It is available publicly. You can download it here in many formats. And other topic that I want to recommend is a very vast list of awesome topics that you can look at. This is basically okay, so this is a list of awesome projects that you can look at, and it is divided into different categories, so platforms and so on and so on and so on. Right now we want to look at the development environment. Where is it? Here. So if you want to dive a bit deeper into, for example, GitHub, you can click here. And then here you have awesome GitHub, which means that you also have a lot of other links to resources that can help you operate GitHub in a more advanced way, or become a power user and extend it, use another features that I have not explained right now, which we don't have enough time for. And there are also some facilities here, like GitHub cheat sheet. So here's the explanation of how GitHub works. Yes, why the reason why I recommend this list is this is a virtually limitless resource which can read and read. I've read a few of those categories, and it is really vast. You can learn so much, and from this main awesome repository, you can jump off to many topics that you've probably never heard of and learn about them. Okay, so we have a question also. We have stashed that info because it was not necessary to be public, right? So the stashing is a way for us to hide the changes that we've done locally for now. So we hide those changes for now. We can operate on the files in the meantime, and those changes are saved in a separate place, which means that they will not be destroyed, they will not be overwritten in any way, and they can be then applied to other working state of our directory that we have. So we can really decide if we want them to be public or not. but for now they are only hidden, so they are not overwritten. In this example, we wanted to pull the changes from our remote repository, but we had some other changes on our local system, and we didn't want to override them, so we hid them for a minute. We applied the changes, and then we applied this stash on top of whatever has been downloaded, pulled from the remote repository. This is just a convenient way of hiding our changes. We don't have to modify those files back to the previous state. We can just hide it for a minute. Okay, any other questions? I see that someone is typing. If we have enough time, I will also explain the very mysterious of rebasing in a moment. Okay, so the question is, how do you go back to the previous version before changes and develop there? So yes, I've said that we can go back to our changes, and how it is done. How is it done? Okay, let's add those files. We don't want to lose them. So if we want to go back, we can reset our changes, as you can see here. And there, if we go to git reset, yes, by the way, I really recommend this a bit on the detailed side, but it explains very well what you can do with those commands. And if we go to here, so there are at least two types of resets you can do. The first one is git reset hard. Git reset hard basically goes back to previous commit, but it also destroys, let's say, our working directory in a way that we are not able to retrieve the files that we have modified. So let's do that. Git status. We have important log and something in the public. So git log, add the directory to gitignore. So assuming we want to go back to the previous commit, we can do and what it says is that the head pointer is now at this commit, which, as you saw a minute ago, was the previous one. I mean, not the last commit, but one before. And yes, here. So we went back to this commit, and as you can see, all of the changes that were made from this previous commit to the last one are lost because we went back. So git status. And also the files which were not tracked are kept because they okay, so the way of explaining it that Git is basically not allowed to modify the files that it is not tracking. So if we are not tracking those files, and we were not, then Git is not allowed to delete them. So even though we went back with git reset hard, which means that change all of the files in the working directory, we did not modify the ones that are available here. Then another way, git ignore. Let's add what we had before. Important. So git add git ignore. Git add. Now you can see that we have made another commit, and is it still saved? Yes. So what we have just done is reset ourselves to a previous version of our repository. That is the commit that was again before the last one. However, with the option solved, it actually keeps what we have modified. So it doesn't delete the files that were tracked by Git. It keeps all of the changes. However, it resets the Git history. Okay, another cool thing that didn't show you, git diff. If a file is in the stashed stage, if we try to git diff it, we don't see it. So useful command is cached. So if we had already staged the file, if we already marked it for a commit, we can check it this way instead of standard diff. So let's assume that we now want to commit it again, but with another message. And with we can see that this commit that we went back is still there. However, there's no commit I mean, the commit that is after it is not the previous one that we made, but the new one. So we sort of rewrote history. I talked that it is, I've said at the beginning that in Git it is hard to modify what you have done in your repository. However, it is not impossible. So this is one of the ways. Is there another question? No. So another way that you can do that is with something that is Git rebase. Let's quickly see what it is. So Git status. We are on the master branch now. If we go to Git checkout, Git checkout. If we switch to the branch test, now we, for example, create some other file. I don't know, file. Let's make it. Write something interesting here. Status. Ignoring all of the other files. Well, okay. Let me show you what is happening right now. Git log. On the test branch, we are currently on this commit, which means that .gitignore does not exist right now. Which means that all of these files are still visible. However, let's focus on file.txt. If we add file.txt, Git status, we want to commit this file on the test branch. So let's do that. Commit. So you can see that if we commit, we don't actually specify which file we want to commit, but only those in the staging area will be committed. Git. We've created a new file. We are right here. How to show it visually. So now. Now, what we have done previously was merge those two branches. So we had master, we had test, we merged them. There were some conflicts, and basically the commit history looked like this: one branch, another merged. What if we want to rebase? What rebasing is another form of merging those branches. However, after that, we will not see another branch extending from the master one, but the commits that were made on the test branch will just be added to the top of master branch. So they will not be visible as an extension and merging, but will as if they were committed on the master branch. Let's try to do that. It may have a problem, but we'll see. Okay, so there were some conflicts here. As you can see, graphs.py was modified. Let's see what was changed there. And this was our from the test branch. Let's delete this. and the standard procedure add graphs. Yes, so the information that you get from Git are very useful. All conflicts fixed, you can give base continue. So it's not a standard commit, but is it? No, I've added it. I did something else. Wait. Okay. So what I wanted to show you. Okay, so this is going to be difficult. So I will explain it, maybe. Git rebase, yeah, as I've said, it applies those changes at the top, not merges them. So this graph is horrible. We these two yes, this is the problem. So okay, so this better illustrates what show, because the Git log graph is a bit confusing. The last change that we made on the test branch was this one, and this has been applied on top of all the other changes made in master. So to everyone else looking at this repository, it seems as if it was made on that branch. This is basically the whole gist of it. And with that, I think I'm gonna leave you. If you have any other questions, please post them in the version control channel. And yeah, it was great talking to you.
Thank you, Szymon. It was a very good seminar. I think we all learned a lot, and I think Git will be much easier and GitHub from now. Thank you very much for that. I just wanted to plug in the NGS virtual gathering that we are holding in September. I will also post about it in the news channel, but just to give you a small idea. So the virtual NGS symposium is going to take place on Discord and on YouTube on the 24th and 25th of September. We are still open for abstract submissions till August 13th. We have some great keynote speakers already booked, Akros Ratan, Roser Ventotormo, and Christopher Yao. You can read all about them on our webpage. As I said, I will post all the info in the news channel, so head there to get your place for the seminar. They are not very limited, so everybody will get the chance. And maybe an abstract of your own. If you have anything you would like to share with us, we would be very happy to listen to you. Thank you again, Szymon. It was really great to hear from you, and see you all next week.